Bismillahirrahmanirrahim. Wassalatu wassalamu ala Rasulillah al-Kareem. How are you, students? I hope that you are in good health and you are in the best level of Iman, inshallah. Okay, so this is our second class, second online class. In our previous class, we just learned the basics of this chapter, energy transfers, right? Okay, so inshallah, today we are going to learn the rest of the concepts in this lesson. Okay, concepts of this lesson, and also I'm going to give you an assignment. You have to write the chapter questions. Okay, so I'll give you a day time, 1 day, maybe 1 hour, 1.5 day time, inshallah. Maybe you can give me on Monday, yeah, 13th of April, inshallah. Okay, so I give you 2 days time, inshallah. Okay, to complete the chapter questions. They are very less, and the submission time, I think it will be 3 p.m. Okay, so 3 p.m. is your finishing submission time. Okay, so you know how to submit. You just have to send me a confirmation by just sending a tick mark and the subject and the assignment number. Okay, so this is assignment 2 for you. Okay, so let's move on to the next concepts. Okay, so today we're going to learn about efficiency. Okay, so lastly we learned about the conservation of energy, right? Okay, so today's topic will start with this: useful and wasted energy. Okay, so we already discussed you know uh, about this term, what energy means and from where do we get energy. Okay, so energy is the ability to do work, and we get energy from fuels. It can be oil, it can be wood, or it can be anything. Okay, and there are different types of energies, gravitational potential energy, kinetic energy, then you have electromagnetic energy. There are various types of energies we discussed. Okay, so when it comes to physics, physics is the study of objects. It's the study of you know physical things. So it is also about the mechanical stuff. So when it comes to making a machine, the first thing where an engineer will think, the first thing which he will he will contemplate is on energy consumption. Okay, so energy efficiency of a machine is the first priority for an engineer. Okay, so what is efficiency and why energy is priority, we will learn in this class. Okay, inshallah. So these are two terms which you have to learn for today. Okay, useful and wasted energy. Okay, so what is useful energy? Useful energy is the energy transferred to where it is required in the form that it is wanted. See, for example, you like to light up your house. What do you want for that? You need a bulb or a tube light. Okay, so this tube light is going to convert the electrical energy into light energy. Okay, so the tube light should not get heat up, because when it heat up a lot, because when it heats up, the electrical energy converts to light energy at the same time. Because of the excess heat, it also gets converted into heat energy, that is electrical energy. We don't like this electrical energy to convert into heat energy. We don't want this to happen. We just want the light. Okay, so here the electrical energy converts into light energy. This light energy, this we name as useful energy. Okay, useful energy is what we want. Okay, and the heat energy, which is a side effect, and that is known as wasted energy. So wasted energy is that which we don't need. Okay, and we don't like it to happen. Okay, so this is how it goes. Okay, so mostly this wasted energy, it spreads out into the surroundings. Okay, and this is usually in the form of heat energy, sometimes even sound. For example, someone drives a car or a bike, when it moves, the fuel is used up, so it moves the fuel. The chemical energy is converted into mechanical energy. At the same time, it also produces some sound inside the engine, correct? So that sound is not needed, and that is known as wasted energy. Okay, so it converts into the wasted energy. It's sometimes in the form of heat, or sometimes it is in the form of sound. All these things, okay, they spread to the surroundings. Okay, and it is very difficult to concentrate this energy again to make use of it. Okay, so now we come to this term, energy efficiency. What is energy efficiency? It is a measure of how useful energy is converted by a device. Okay, so I just, like I told you, how, why an engineer, uh, concentrates more on efficiency. Okay, and the reason is this. Okay, so to reduce the wasteful energy. Okay, so energy efficiency, calculating energy efficiency helps us to reduce, or to find out how much energy is wasted and how much energy is used. Okay, so you might not find this in your textbook. There might be explanation, but might be difficult for you to understand directly from the textbook. Okay, so just follow what I'm telling you. Okay, energy efficiency is a measure of how useful energy is converted by a device. Okay, it also at the same time gives us a picture of wasteful energy. Okay, so totally it is energy efficiency. It helps us to make an efficient machine, okay, which reduces the, also tells us about how much energy is used, wasted. Okay, so this is the formula. It's very simple. Efficiency equals useful energy output by, divided by total energy input. Okay, so you might get a question, you might get a problem based on this concept. Okay, you have to use this formula. We'll look at the next slide. Okay, okay, so energy efficient light bulbs, what does it mean? Okay, so it means that these bulbs, they produce more useful light energy for the same amount of input electrical energy. That is, there is no energy loss due to heat or sound, anything like that. Okay, so they waste less energy to heat. Okay, so if we read the labels on a bulb, on the box of the bulb, when we buy a bulb from the shop, electrical shop, okay, we will find this statement written on the box, that it is a very efficient, 100% efficient bulb. So that means the electrical energy is not converted to any unwanted kind of energy, for example heat or something like that. Okay, okay, so just let's go through a question, a sample question. It says calculate the efficiency of an electrical motor if it produces 48 joules of useful kinetic energy when supplied with 80 joules of electrical energy. Okay, so now here you have to find out which is the input, which is the output, and you need to calculate what, you need to find out which one you need to calculate. So firstly you will write the formula. Efficiency equals useful energy output divided by total energy input. Okay, then efficiency equals 48 joules divided by 88 joules. 48 joules is your useful energy. Okay, efficiency of an electric motor if it produces 48 joules. Okay, produces, okay, this tells us that this is the output. Okay, produces, output, they correspond to one another. Okay, so this is the output energy, so directly we'll write here, then divided by 80 joules. Okay, because the motor is supplied with 80 joules, we use this as total energy input. Okay, so this is the final answer, zero point 0.6. Okay, question number 2, same kind of question, but here there is one change, small change. They're asking to find out useful light output of a light bulb. Okay, just go through this question. Okay, just pause the video and just go through the question. I'm just moving it fast. Now you might also get a question which might ask you about the percentage efficiency. Okay, how to do this? This is again very simple. Just multiply the final answer with 100. That is your percentage efficiency. That's it. Okay. See, this is a sample question for you. Okay, same kind of formula you're going to use. You're going to substitute the values, and for the final answer you're going to multiply with 100, and that's your answer. Okay, 12.5%. Okay, just pause the video and just find out how it is done. Okay, so this is you can use this as a homework as well. Okay, you can use this as a homework to work out. Okay, so this one you just pause and or take a screenshot of this slide, and these are the answers for these questions, the questions. Okay, just note down the answers. Okay, don't try to look at the answers first, work out, then finally you cross check with your answers. Okay. Okay, our next topic is Sankey diagrams. Okay, so again, Sankey diagrams are used to show energy transfers. Okay, again, it shows know how much energy is used, wasted, all those things. Okay, so basically, you have two, three arrows in the diagram. You have to draw a big arrow, then an arrow downwards, and another arrow upwards, something like that. Okay, I'll just show you one image, just a minute, from the textbook directly. Okay, so this is from your textbook. This is from page, just 1 minute. This is from page, okay, 138. Okay, so it's your book back questions. Okay, so just let's go through this question. Question number 2. It says copy and complete the following Sankey diagrams. Remember that the width of the narrow arrows must be proportional to the amount of energy involved. This has been done for you in part A. Okay, so uh, this has been done for you already. Okay, let me discuss how this has been drawn. This Sankey diagram is for an electric lamp. Okay, so this is the input energy. Okay, this is the input energy, 3600 joules of electrical energy supplied to the lamp. Now you have to draw this in your paper, that is in your classwork. Okay, from here to here, from the top to bottom. Okay, so the length should be proportional. See, this is 3600 joules, so you have to uh, you know draw a line, that is you have to draw this, this area from top to bottom. Okay, with a measurement of 3.6 centimeters. Okay, so it should, see, this 3.6 centimeters, it corresponds to this energy, 3600 joules, right? Okay, and this 1200 joules of light, this is the useful energy. Okay, this is the useful energy. Now what remains? Okay, the remaining energy, joules, again another you know the remaining 2400 joules, that's the wasted energy that you have to draw here downwards somewhere. Okay, you have to draw downwards. Okay, so basically the useful energy, part, you will draw it straight, and the wasteful energy area, or that part, you will draw it downwards, towards downwards. Okay, so this is how you are going to draw your Sankey diagram. Okay, so again, Sankey diagrams are there to represent the energy equations. It will show us how what is the input energy and what is the output energy, useful energy, and what is the wasteful or wasted energy. Okay, Okay, so when you're drawing your Sankey diagrams, just keep in mind all these points. Okay, so these are energy flow diagrams that show how well a device uses energy. The width of the flow of arrow is proportional to the amount of energy, and wasted energy is shown flowing downwards. This is very important. Okay, wasted energy should always should point downwards. Okay. Okay, girls. So this is it for today. Inshallah, we will meet another day. And for you, uh, you have homework. Okay, the homework I'll just send you through WhatsApp, and also I'll tell you now. You have to write the chapter questions for this lesson. It's page number 137 to 138. Okay, so I hope that you will, inshallah, you will finish your assignment, and you will submit it on Monday, inshallah, 13th of April, and your timings for submission is 3 p.m. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.